All right, folks, we're going to get started and we are going to take a break from graphing. We're going to work with writing equations of quadratic functions in vertex and intercept form. So you have to remember back to your vertex and intercept form and think about what they are, and then we're going to write equations today. So let's get started. First of all, vertex form is y equals a times x minus h squared, quantity squared, plus k. So if we remember that vertex form, then writing the equations of these quadratic functions will be simple as pie. So here we go. We've got a vertex. Okay. The vertex is represented by h and k. Remember that? And then we have this random point up here. Okay, we're going to plug those values into our equation and find the actual quadratic equation. So I'm going to say y is equal to, oh, I don't know what a is. A is unfamiliar to me. I don't know what x is, but I do know what h is. H is negative 2. So if h is negative 2, I want to do the opposite of negative 2, or say negative 2 squared plus my k is negative 3. Okay, so then I'm going to rewrite this as y equals a x plus 2 squared minus 3. Okay, we're one step closer to the equation, but not quite there. We've got to use this random point, and if you understand what a random point is, it's just a point anywhere on your graph, and it represents your x and your y. So you're going to plug the 0 in for x, you're going to plug in the 5 in for y, you're going to keep a and save it, leave it there. Okay, and then you're going to go ahead and do all the order of operations that you know how to do and solve for a. So our goal is to find a given all the other pieces of information that we know. So 5 equals a, 0 plus 2 is 2, 2 squared is 4. Now, this is tricky. Make sure that you bring down a multiplication sign there. If you put a plus sign, you are not going to get any of these equations right. So you really have to make sure that you follow order of operations and that you know where those multiplication signs are. So if I were to rewrite this, it would look better if I wrote 5 equals 4 times a minus 3. This right here seems easier for me to solve. Add 3 to both sides. I get 8 equals 4a. Divide by 4. And I get a equals 2. Now, if I know that a equals 2, I can come back up here to my equation, take out the a, and put the 2 there. And that will be the quadratic equation of this function. Okay, let's try it again. This time I don't give you a picture, I give you words. Okay, same thing, just no picture. We still know what the vertex is, so we're going to write down the vertex form here. Okay, that's y equals a, and in parentheses, x minus h squared plus k. We're going to plug in our h and our k. So y equals a, x opposite of whatever h is. So that's negative 2 squared, and k stays the same. So it's opposite of h, but k stays the same. All right, now we're going to plug in that random point. That random point is our xy. Okay, and when we have our xy, then we go ahead and plug in whatever we have for each. So 4 equals a, 0 is our x. Okay, and then we're going to do order of operations. 4 equals a times, this is 2 squared, negative 2 squared, plus 1. Negative 2 squared is 4. So I got 4 equals a times 4 plus 1. Yeah, I don't like the way that looks, so I'm going to go 4 equals 4a plus 1. Subtract 1 from both sides, and I get 3 equals 4a. Divide by 4, and my a is going to be 3/4. And so I go back up to that equation where I have the vertex h and k in. I take out the a, and I put my new a there, which is 3/4. So just a little bit of algebra and knowing where things get plugged in. Otherwise, this isn't too bad. Okay, let's go ahead and work on the intercept form. Okay, so the intercept form is going to be using, remember, the intercept form that we used, which is y equals a times x minus p, quantities, times x minus q, the quantity of x minus q. Remember, your x-intercepts are p and q. All right, so if I'm given this graph, I'm going to be looking for my x-intercepts. Well, here's an x-intercept. Here's an x-intercept. Now, could I use vertex form here? I could, but I really don't know what the vertex is. So if I don't really know what the vertex is, I'm not going to use the vertex form because I'm not going to guess where that vertex is. I either use my vertex form if I'm given a good vertex, or I use my x-intercepts when I'm given my x-intercepts. So again, we're going to write down what we know. And remember, P and Q are opposite. So your x-intercepts are opposite because we got to set them equal to 0. So if P is -3, then in the equation it was -3, which is really +3. And Q would be opposite of 2, which would be -2. So I'm going to rewrite this one more time. X plus 3, x minus 2, okay? And now what I'm going to do is I'm going to plug in my random point. Here's my random point. And solve for my a. That's what I'm always looking for. I'm trying to find that a. So my random point is -2, -4. So I'm going to go -4 equals a, -2 plus 3, -2 minus 2. Follow order of operations. There's little multiplication signs in between all these things, so we got to do what's inside the parentheses first. A times, that would be 1, times -4. -4 times 1 is -4, so -4 equals a times -4. I like to rewrite it so that it says -4a. That looks better for me. Divide by -4. And a would be 1. Go back up to the equation where I had my p's and q's in there, take out the a, plug in my new a. All right, let's try that one more time. Write the quadratic function in intercept form whose graph has the given x-intercepts and passes through the given points. Again, this time I don't have a graph, but I have the information I need. I have my x-intercepts and I have my random point, which represents my x and my y. So I do y equals a, x minus p times x minus q. Plug in my p and q. Y equals a, x -p, opposite of -p would be that -2, and x minus 1. Now, if you can do that in your head and you know that it's the opposite without writing negative, you can skip this step. I just do that to verify, make sure that you're all thinking about it being the opposite. Now I plug in my random point, my x and my y. My x is -1, my y is -4. -4 equals a. Plug in your -1. negative 1 plus 2, negative 1 minus 1. Okay, now go ahead and remember these are all multiplication. Negative 4 equals a times 1 times negative 2. That's negative 2a equals negative 4. Divide by negative 2, and a equals positive 2. So we've got, go back up where our x-intercepts were, go ahead and get rid of that a, and put the a value that you just found in there. So taking a break from graphing, basically just using some substitution and order of operations, determining our a, plugging it back in, and finding the equation of our quadratic function. Okay, that's all I've got. And I forgot period 2, kind of a shout out to you. Hopefully I didn't do any beatboxing today. See you tomorrow. Bye.